Welcome back to another video, guys. Like usual, I'm going to be providing a quick update as to what happened over the past week. So today I'm going to focus on what I achieved, but also I'm going to be providing a mini lecture covering the main ideas and concepts that I studied and learned about this week. So let's jump into it. So in terms of what I achieved this week, my goal was to achieve, on a rather complete courses 2 and 3 of the business statistics and analysis specialization that I mentioned in the previous video. I was able to do that. I succeeded in achieving my goal. Both courses were very interesting. So the first course 2, was about basically covered the fundamental statistical terminology, as well as distributions and other fundamental concepts such as the central limit theorem. Course 3, on the other hand, was a little different. It still covered very fundamental concepts, but it focused on hypothesis testing and confidence intervals. All of this I'm going to go into more depth later in the video, but just providing you an overview as to what I learned about this week. In terms of strategy, I applied the same strategy, so study the video, recall the information, and then practice by means of using flashcards and completing the questions provided in the course. So there's not really much to report there. It's still working very effectively, and it seems to be the best way to work through this course. As it stands, I have 2 courses left in this specialization, and that will be the focus of the coming week. I have one more course that is about regression analysis, I believe, and then the final course is actually the project where I get the opportunity to combine all of the skills and knowledge that I've gained over the past couple of weeks and actually put them into practice. So I'm looking forward to that as well. With that out of the way, I'm going to go ahead now and jump into the lecture that I've created. The lecture is going to cover a lot of the fundamental concepts that I mentioned earlier in the video, along with some other things too. But before we do that, I just want to share the objective of this lecture. The objective of this lecture is not to provide you with a very deep understanding of the concepts involved. For this reason, I'm going to leave out a lot of details. I'm going to leave out a lot of the maths associated with each of the concepts. Not because I don't think you guys could understand any of this, but rather because I don't have a lot of time to make these videos, and a lot of the details are beyond the scope of what I'm trying to teach you guys. So if you come away from this video with a good high-level grasp of the concepts involved and why we use them, what they are, and their relevance to statistics, then that is a success to me. So just wanted to let you guys know that is what I'm trying to do here. To begin this lecture today, I thought it would be a good idea to begin with just providing an overview as to what will be discussed. So the core ideas in today's lecture will be the basic statistical terminology, distributions, confidence intervals, hypothesis testing, and then we're going to wrap up the lecture with a summary, which will highlight how each of these ideas are connected to each other. So in terms of the terminology, unfortunately, the only way to really teach this is to read off of the screen, and the only way to learn it is to kind of memorize, apply in context, which we're going to do in a second. But to begin with, why is the terminology important? I actually think a lot of people skip over the terminology, and I think it's kind of a mistake. It's not the whole picture, of course, but I think that if you understand the definitions, it really helps, because when you go back to first principles, when you're solving a problem, you have the knowledge, you know what you're working with, and that allows you to actually better solve the problem because you have a solid understanding as to like what each variable in the problem represents. Another reason why I want to start with the terminology here is that as we go through this lecture, it's going to build on these ideas. So later I might start speaking about the population, the mean, and so on. And by that point, you'll actually have a good idea as to what that is, because we're addressing it now. So the population is a complete data set that we're interested in studying. The sample, a subset of data of the population that we are interested in studying. Mean, the average of all the values in the data set. Standard deviation, the average distance of each data point from the mean. Discrete data, data that can take on specific distinct values. These are typically whole numbers. Continuous data, a data that can take on any given number within a given range and can be expressed by an infinite number of possible values, including decimals. Probability, a numerical measure representing how likely an event is to occur. Alpha, the probability that a given event will not occur. With the terminology out of the way, I actually wanted to show you what each of these terms mean in context, because right now they might just seem like words on a screen, but they're quite important to know. So I thought it would be a good idea to provide an example to go through together, so you could kind of understand what these mean. So I'm English, I'm from the UK, I'm currently living in the UK as we make this video. And as you can probably imagine, a big stereotype is we love to drink tea. And to be honest, it's true. A lot of people here love to drink tea. So let's just pretend that I was interested in finding an answer to the following question. So, on average, how many cups of tea do people drink in the UK per day? Let's just say that that's the question. How do each of these terms that we've just addressed relate to this question? So, if I was to answer this question, I would first need to decide what my population was. In this case, it would be all the people that live in the UK and drink tea. I'd also want to know what my sample is. In this case, I chose all the people that live in West Yorkshire. But again, by definition, the sample is just a subset, a smaller group of the population. So because the population is geographical in this case, based on area, then it would just be a smaller area. So I've chosen a county here, but I very much could have chosen a city, and even a country for that matter, as the UK is composed of many different countries. So just a heads up there. The mean in this case would be the total cups of tea per day divided by the total number of tea drinkers, and that would essentially give us the average number of cups of tea that people in the UK drink per day. Depending on if we do that for the sample or the population. I'll explain what that means later in the video. Standard deviation. So this is a metric that people using statistics will apply to learn about the data. So what is the standard deviation? I said it was the average distance of each data point from the mean. What the hell does that mean? You might be thinking. Allow me to explain. So on this diagram that I've created, this bottom black line is the x-axis, which will represent the value of the random variable. The random variable, it just means the variable of the experiment. In this case, the experiment is a question that we're interested in finding. So in this case, it's the number of cups of tea. That's what's represented on the black axis here. We have this red line. This is the mean, the average value that we've just discussed. Each of these black lines represents the distance from the mean, and then these blue dots represent the data point itself, the value, one of the values in the data set. So again, the standard deviation would just be the value that we get after performing a certain calculation. And as I said before, I'm going to leave the maths out. It's very simple, but just leave the maths out of this this lecture for today. But we would use some sort of mathematical function specific to standard deviation to then calculate the average of these distances that we see on the screen right now. Why would we want to do this? So if you think about statistics, it's a field of mathematics that we use to make inferences about data, essentially. And this metric can give us a good idea as to what's happening in the data. More specifically, the standard deviation is a metric that we use to understand how dispersed, how spread out the data is in the data set, which could be a useful thing for us to know as we analyze the data set. So going on to discrete data, the discrete data in our case for this question would be the number of cups of tea. But why isn't the number of cups of tea? Why isn't it something else? So discrete data, as we said, is data that can take on specific distinct values, which are typically whole numbers. So if you think about cups of tea, we can have 1 cup of tea, 2 cups of tea, 3 cups of tea, and so on. We can't really have 5.689 cups of tea. And for this reason, this data is considered discrete. And the reason for this is because if you imagine a graph, again with the x-axis representing the number of cups of tea, then we can only have a number of finite values between one value to another. So let's just say one cup of tea to 4 cups of tea. In between these two values, I can only have a finite number of values that occur. So 1, 2, 3, and then we get to 4. And for that reason, by definition, the data is considered to be discrete, which naturally means that continuous data is kind of the opposite. So to better explain what continuous data is, I actually wanted to change the question a little bit, because our original question doesn't contain any continuous data. It's not a question that needs any continuous data to be answered. We need discrete. It's a question that requires discrete data to be answered. So to elaborate, so to change the question is now, on average, how much tea do people in the UK pour in their cups when preparing their tea? It's a new question. In this context, the continuous data would be the volume of tea poured in each cup. So why? So if you think about the volume of tea poured into the cup, it could be a whole number, but more likely it's going to be a decimal, right? It's more likely going to be 330.689 milliliters, depending on how precise the instrument is that we're using to measure the volume. So again, if we go back to that visual example of the graph, on the x-axis we have the volume of tea poured into each cup. And if you think about the values again, let's just use 200 milliliters and just 201 milliliters. Even between the seemingly small different values, we could have an infinite amount of values that occur, right? I could have 200.00002 milliliters. I could have 202.683 milliliters. As you can see, there are so many, an infinite number of values that could be taken on by our variable in this case, which is the volume of tea poured into each cup. And for that reason, the data is considered to be continuous in this case, and therefore the continuous data is the volume of tea poured in each cup. So in terms of probability and alpha, if we think about what probability is, so probability is the numerical measure of how likely an event is to occur, and alpha is the probability that a given event will not occur. So that's the opposite of probability in a sense. So in the case of our example, again, I just want to change the question a little bit so you can kind of understand what I'm trying to say. So let's just say the question is, what is the probability that on average people in the UK drink 4 cups of tea per day? The event that we're interested in here is the result of this question being 4 cups of day that the people in the UK drink per day. That's the event. So the probability would be, what is the chance, how likely is that to occur, that the result is 4 cups of tea per day? And as I stated earlier, I'm going to leave a lot of the math out of this lecture for the reasons I stated earlier. But one key thing that you really need to know is that probability can take on a value between 0 and 1, and can also be expressed as a percentage. So a little bit more detail on that, actually. So if you do know that the probability is 0, this actually expresses the idea that the event is impossible, like it cannot occur. and then 1 would mean that the event is certain. And in terms of the probability being expressed as a percentage, here I just wrote down 0.95 as an example. So we could express it as a percentage and say if this was true, we would say that there's a 95% chance that the people in the UK drink on average 4 cups of tea per day. Alpha, really easy to calculate. It would just be 1 minus the probability that we've calculated, and in this case that would be 0.05. So now that we have covered the terminology, this would be a good moment to introduce the second topic, distributions. So what are they? So distributions are essentially a way in which we model the data that we're dealing with to see how it's distributed, how it's spread out. And this is important because if we can learn how the data is spread out, how it's distributed, we can begin to understand the data itself and make the necessary inferences, the necessary interpretations to learn more about the data, or learn about the certain qualities, the quantities of the data that we're interested in. So for that reason, distributions are important. Another important thing that would be a good thing to talk about now is the actual significance of, or rather the relationship between the population and the sample. So at the start of the lecture, I introduced those two terms, and it might not have seemed like they had much significance, but they actually have quite a lot of significance. So if we return to the population in the context of the question that we were trying to solve earlier, the question of, on average, how many cups of tea do people in the UK drink per day? The population in this example would be all of the people in the UK that drink tea. But if you think about it, that's an absurd amount of people, meaning that it would be very hard for us to actually contact each of these people and get the data we need to evaluate the population itself. And that's where the sample comes in. That's the reason we take a sample, because we can take the sample. It has data that is representative of the entire population that we're interested in. And then we can start making the necessary inferences and calculations about the sample to actually learn more about the population. And the reason for this, there are many theorems, there are many mathematical formulas and operations we can use to do this. And fundamentally, that's why the sample is used, because if we know how the data is distributed, and this is why the distribution is important, we can make the necessary inferences. If we can make the necessary inferences about the sample, we can learn about the population, which is ultimately what we're interested in. So in terms of types, there's two main categories, discrete and continuous. And then within each category, there are different variants. And I've just highlighted the most popular kinds of distributions within each category. And the main difference between discrete and continuous, this is actually quite easy to explain given the fact that we've covered the terms discrete and continuous data. It's just the data that they use for the distribution. So as you can imagine, discrete data uses, discrete distributions use discrete data, and continuous distributions use continuous data. And that's the key difference there. But in terms of the actual kinds that we see below, the things that distinguish each of these distributions from one another are the characteristics of each of them. And commonly speaking, where the mean is located, the value of the standard deviation, along with the mass, the probability density function or probability mass function, which I'll explain in a moment, the differences between those parameters, let's say, is actually what makes each of these distributions unique and therefore different from each other. So just that's why we have all these different kinds of distributions essentially. But if I return back to this slide, because I introduced two new terms there, so the probability density function and the probability mass function. Conceptually, these are actually the same thing because they're both used to calculate the area under the curve of a distribution, and the area under the curve of a distribution actually represents the probability. So if we use the relevant function, it creates the relevant distribution, and because of that, we can actually learn what the area is underneath the curve, and therefore calculate the necessary probability of an event that we're interested in. So the only difference between the probability density function and the probability mass function is what kind of distribution we're dealing with, or what kind of distribution, and also what kind of data we're dealing with. So the probability density function is just the mathematical function that we use for a continuous distribution, which is using continuous data, and then the probability mass function is just the mathematical function that we use for a certain kind of discrete distribution in order to calculate the area under the area of the distribution, essentially, and therefore the probability. Now that we know what a distribution is, we can actually start to begin to delve into the concept of confidence intervals. So a confidence interval is by definition at least, is an interval with a given confidence level or probability attached to it. So what does that mean? That basically means that if we make a prediction, we can learn how likely that outcome is to occur within a given range of values. So if I return back to our question, we're interested in finding the number of cups, but let's just say that we wanted to know how likely it was that the result of that question was 4 cups. We just focused on that. We could assign a confidence level, so a probability as to how likely that event is to occur. In this example, let's use 95% because it is on the screen. And that would essentially mean that after performing the necessary calculations and creating the confidence interval, we would know that we have a 95% chance of the result being 4 cups within a given range of values. That's essentially why we use the confidence interval, because it gives us a certain degree of certainty as to how likely something is to happen. Another important thing to mention here, and you might be thinking about, is how is the confidence interval calculated? Unfortunately, this is another mathematical situation. But depending on the kind of distribution that we're dealing with, so if it's a continuous distribution or a discrete one, and then on top of that, which kind of discrete or continuous distribution we're dealing with, there are certain formulas that we use in statistics, and we just input the relevant variables, such as the mean or the standard deviation or the sample size. That are really common variables in these formulas to calculate the necessary confidence interval that we're interested in. So apologies, guys, that is out of the scope of the lecture, but I hope with the way that I just described it, you can understand conceptually what I'm trying to say. The final topic that we need to speak about today is the idea of hypothesis testing. So hypothesis testing is the idea that we want to check if a claim that we're making about the data is true or false, essentially. So if I give you a concrete example, let's just pretend that I claim that the average house price in the UK is greater than or equal to £90,000. Evidently, my claim here is that the average house price in the UK is greater than or equal to £90,000. I would then set up the appropriate hypothesis test, collect the necessary data, and then based on the data, I would then determine whether or not to accept or reject the hypothesis that I've proposed. And as you can imagine, this is a really powerful tool because maybe we believe something to be true and it turns out to be false, and vice versa. And it also allows us to get a deeper understanding of the true values that we're interested in, and the true behavior of the data set that we're also interested in too. And in a way, this is actually how all of these ideas are related, because if you understand the key terminology, you can then begin to understand the distributions, and the distributions are a fundamental concept because depending on the type of distribution that we're dealing with, that actually changes the way in which we calculate the confidence interval, and it also changes the way in which we conduct a hypothesis test. So if you know how to interpret the distribution you're dealing with and what makes that distribution quite distinct, you'll be able to perform the more advanced statistical analyses to learn more about your data and interpret it in a meaningful way. And that actually brings us to the end of this video, guys. The lecture was very ghetto. It was very basic, but I just hope that you learned something new. That would make me really happy if that was the case. It was also my first lecture too, so any feedback is welcome, good or bad. To me, feedback is feedback. It's a really good tool to grow and learn. So please, if you thought there was anything I could have done better, anything that wasn't clear, please let me know. It would be greatly appreciated. And as always, thank you for watching, and I hope you learned something new today.